Example 15. Find the domain of g of x equals the square root of x plus 2. Now, domain is any value that when you substitute to this function will make the function defined, okay, as real value. So we got to find all the x value such that when you substitute to this function g, guarantee you would get a real value or defined. Alright, now you know that this is a radical function, right? This is a radical function, and this radical function is defined as a real number, okay? Defined or exists as a real number if the radicand, which is x plus 2, is non-negative. Equivalently, you say the radicand greater than or equal to 0. Okay? So that means we need to find the x that satisfies this condition. The radicand must be greater than or equal to 0. Okay? If you can find those x that satisfy this radicand, that means you can. Those are the domain. Okay? Those x satisfy that would make this g of x defined as real number. That means those x define the domain of this function g of x. Alright, so let's find the x, okay, that would make this function g of x defined as real number. So I would solve for the radicand greater than or equal to 0, and the radicand is x plus 2, right? Radicand is anything inside this radical or this square root. So x plus 2 greater than or equal to 0. So you need to solve for x. That means I subtract 2 on both sides. X plus 0 greater than 0 minus 2 is negative 2. Simplify further, you have x greater than negative 2. So this is the domain of this function g of x. Now, if I ask you to write the domain, okay, to write the domain in set notation, you would write domain. This is domain, okay, in inequality. But what if I ask you domain in set notation? Remember set notation, you would use braces. You would talk about the variable of the function g, which is x, right? Next, you use the vertical bar, and then this field right here, you would describe what is x. We solve for x, right? So x is greater than or equal to negative 2, so you would put x is greater than or equal to negative 2. So this is the domain of g of x written in set notation. Now what if I ask you to write the domain in interval notation? Now this is recap. You can start with number line first. That would help you visualize and write the domain in interval notation. So start with negative 2, right? So x is greater than or equal to negative 2. So that means you would use the brackets, right? Because you include the endpoint negative 2 right here. So x is greater than, so it got to be on the right side, right? The greater side. So x is greater than or equal to negative 2. So domain in interval notation is the smallest is negative 2, right? And we're including it because there's equal here, bracket there. So start at negative 2, we include the endpoint, and all x is greater than or equal to negative 2, right? So all the x, so x increasing infinitely, so getting bigger and bigger, got to be approaching positive infinity, right? So you would write infinity. And for infinity, because it's a huge number, we don't know how big it is, it's uncertain, so we use right parentheses for positive infinity. So there are three ways for you to write the domain: in inequality notation, which is x greater than or equal to -2. In set notation, you use braces. In interval notation, you use bracket, parenthesis, or any combination of that. So this is how you solve the domain of g of x. So any value of x that is starting at -2 and bigger, any value after -2, you can substitute in here. Guarantee would make this radical or this square root defined as a real number. So that means the function g of x is defined. Okay.